Students, in my last video, I told you the basic definition of damping rule of Z transform. Now, let us apply it on few questions. Now, what is the first question? Find the Z transform of k to the power n. Okay, so I have to find out Z transform of k to the power n. I can make it out. I have n multiplied by k to the power n. So, how I should start? I should first write what is the Z transform of n. Right, Z transform of n is what? Z upon Z minus 1 square. You need to remember the formula, student. Now, this is multiplied by k to the power n. So, we know that damping rule says that when a function un is multiplied by k to the power n, then the answer is Z transform of un. But in place of Z, you have to write Z by k. Correct. So, Z transform of k to the power n is equal to Z by k upon Z by k minus 1. Okay. See, I know the answer is Z upon Z minus 1 whole square. So, what I am doing in place of Z, I am just writing Z by k as per this. So, now if you solve this, Z by k you write here. Here you take the LCM. So, Z minus k it will become and k here. And remember this is square. So, the next step what will happen? Z by k is there. This is Z minus k square. And this k square it will go to numerator. So, k square. So, k and k square get cancelled and you get the answer as Z k upon Z minus k square. So, this is the answer for the first part. Now the second part is this thing. Now they are asking me. So now let us do the second part, that is Z transform of e to the power minus an into n. Now can I write down this as Z transform of e to the power minus a to the power n and into n? So what is happening? This e to the power minus a is a constant, some k, which is raised to power n. So I can compare this to my previous thing where k value is equal to e to the power minus a. So what will be the answer? Z transform of e to the power minus an into n is equal to, in place of k, I will just write e to the power minus a. So z e to the power minus a upon z minus e to the power minus a square. Simple. So I got the answer. So that is what you have to do. Somehow you have to write it as a constant to the power n. The moment you write constant to the power n, you get the answer. Okay. So now let's move to the next question. Now see, they are saying what is a Z transform of k to the power n square. So you should remember what is a Z transform of n square. So Z transform of n square we have already done in the previous video where I introduced the Z transform. This is equal to Z square plus Z upon Z minus 1 ka cube. So what is a Z transform of k to the power n square? Simple. In place of Z you have to put, you can remember like this, in place of Z you have to write Z by k. That's it. Right. So let me substitute Z by k square plus Z by k upon Z by k minus 1 cube. So let me simplify it. So here it becomes Z square by k square plus Z by k upon Z minus k. I have taken the LCM cube. Right. Next step, Z square. If numerator I will take LCM, it will be k square. Right. So Z square plus ZK. When you take LCM, k square, and here it is k. So k will go there. And this k square comes and sit here. Here it is already Z minus k cube. And this k cube I am writing here. Right. So this k cube and k square will get cancelled. So you will have k z square plus zk upon z minus k cube. So simplify this. You will have k z square plus z k square upon z minus k cube. right? So z square k plus z k square upon z minus k cube will become your answer. Now in the second part of the question, what I am saying, I am asking you this thing. So again, what I can do here, you have to write that z transform of e to the power minus n square is equal to z transform of e to the power minus a to the power n square. Means in place of k, you should write e to the power minus a. So what will be the answer? Answer will be equal to, in place of k I am writing e to the power minus a. So e to the power minus a z square plus z e to the power minus 2a. Right, because minus a I am writing. Okay, e to the power minus a and square it is. So upon z minus e to the power minus a ka cube. Simple. So you just have to substitute the value there. Okay, and in case if in exam directly this second part is coming, you write down the formula of k first and then you put the value e to the power minus a. That's it. Okay, now let's move to the next question. Now next question is z transform of k to the power n cube. So again, as I said, if you want to find out this, first you should know z transform of n cube. We know that z transform of n cube is z cube plus 4z square plus z. These all formulas will be used. In fact, when you multiply it by k to the power n also, when you do the inverse and all. So you should remember all the formulas. Right. So this is the formula of z transform of n cube. So what is a z transform of k to the power n cube? As I said, in place of z, I'll put z by k. So z by k cube plus 4 z by k square plus z by k upon z by k minus 1 to the power 4. Now let us simplify this by taking LCM. Don't do the silly mistake in doing the LCM. So very carefully you do. See, in the numerator, highest power of k is k cube. So k cube will be the LCM. So z cube plus 4z square. Now here it is k square. So 1k will come. Plus here 1k is there. So k square will come. That is what we do in the LCM, right? And this k cube will come here. Now denominator, when you do z minus k LCM upon k and 4. Correct? So this, it will be z k to the power 4 will go in numerator and it will get cancelled with that k cube. So outside I'll have 1k. And what is left? K z cube plus 4z square k plus z k square upon z minus k power 4. So this will become z cube k, okay, z cube k plus 4z square k square plus z k cube upon z minus k to the power 4. And when I ask you z transform of e to the power minus n cube, in place of k, you have to put e to the power minus a. So z cube e to the power minus a plus 4z square e to the power minus 2a plus z e to the power minus 3a upon z minus e to the power minus a to the power k. That's it. Simple. So now let's move to the next question. Now next question is cos theta involvement, right? So I should remember the formula for cos and sine because it is required in few questions also which we have observed, right? So now what is a z transform of cos n theta? Z transform of cos n theta is equal to z square minus z cos theta upon z square minus 2z cos theta plus 1. So what is a z transform of k to the power n cos n theta? In place of z, you have to put k by z by k. So z by k square minus z by k cos theta upon z by k square minus 2z by k cos theta plus 1. Remember, if it is minus n, k to the power minus n, instead of z by k, you will put zk. Okay. Now, next step. Take the LCM in the numerator. So, LCM in the numerator will be k square. So, z square minus zk, because I have here only k. LCM is k square cos theta upon this k square goes here. Now denominator also you take the LCM. So z square minus 2zk cos theta plus k square upon k square, which is the LCM. So this k square and k square get cancelled. So you got z square minus zk cos theta upon z square minus 2zk cos theta plus k square. Okay, so z square minus zk cos theta upon z square minus 2zk. So now based on this, if I ask you what is the z transform of e to the power minus an cos n theta. So what you will be doing? You will be writing it as z transform of e to the power minus a to the power n cos n theta. And your e to the power minus a will play the role of k. So in this answer, you in place of k just write down e to the power minus a. So this becomes z square minus z e to the power minus a cos theta upon z square minus 2z e to the power minus a cos theta plus e to the power minus 2a. Correct? So this is how you get the answer. Now come to the next question. You have to find out z transform of k to the power n sin n theta and z to the power e to the power minus a n sin n theta. Again, for this standard result, z transform of sin n theta you should know. Right? See, many time in exam when it is for, they want to ask for more marks, they tell like that. Find the z transform of sin theta, hence deduce the z transform of a to the power n sin n theta or k to the power n sin n theta or e to the power minus a n sin n theta. So that time you first derive the z transform of sin n theta as we have done in the previous video. Right? And then use this result and put the final results. So now sin n theta we know it is z sin theta upon z square minus 2z cos theta plus 1. So z transform of k to the power n sin n theta will be, just put z is equal to z plus k. So z plus k sin theta upon z plus k square minus 2z by k cos theta plus 1. Now start taking LCM. So z sin theta, this k will come and sit here. Denominator it will become z square minus 2zk cos theta plus k square. And this k square down, it will go up. Right? LCM will go up. Right? So k cancel. So zk sin theta upon z square minus 2zk cos theta plus k square. Now if I ask you what is z transform of e to the power minus an sin n theta, then this will become, in place of k you have to put e to the power minus a. That's it. Z e to the power minus a sin theta upon z square minus 2z e to the power minus a cos theta plus e to the power minus 2a. That's it. So this is how you apply the damping rule. It's very simple and you have to remember formulas for inverse Z transform as well. In next video, we will be doing the shifting properties and then inverse Z transform. Like the video, share the video and please subscribe the channel so that you will come to know whenever I'll upload a new video. I'm trying to cover all the topics of your syllabus. In case there is some topic which are missed, text me on YouTube so that I can upload that topic. Thank you.